Good morning. My name is Kelly Luckett. I'm with Greenroofs.com. I'm here this morning with Jim Kirby of the NRCA and Mike Ennis of SPRI. And we're presenting the Green Roofs Wind and Fire panel discussion for the Green Roof and Wall of the World Virtual Summit 2011. Hi guys, you ready to go?
Absolutely, Mike.
Okay.
All set.
Well, Jim gets the floor first. You're up, Jim.
Okay, we're going to jump right into this. I guess I'll give you a quick 30 seconds on who I am. James Kirby, AIA means I'm a registered architect. Actually, it doesn't. It means I belong to the American Institute of Architects, but I am a registered architect. I've been with NRCA for about 15 years now. Been doing technical services work for over a decade, and now I've been doing a lot of things in the communication world, audio, visual, all this kind of stuff written. So we'll just keep right on rolling here. Mike, how about another slide, please? I think this is going to just be a fun conversation today, everybody. So good. I think I get to start this off without even too much of an explanation of RP-14, but I think what we all need to recognize is RP-14 is a wind design standard for building green roofs on rooftops. I get to start off here because roofing contractors are often one of the trades associated with this, and the people who are doing the installing, who have the direct contract with the building owner, they get to be first in line for any of the problem solving, and perhaps if things would even be further of a disturbance than that, if there needs to be legal involved in some way, contractors then installers are first line of defense against all that kind of stuff. So what NRCA is looking at is making sure that things on roofs, vegetated roofs, and anything else we put up there, penthouses, photovoltaics, meet the requirements of the building code. These other guys are going to give you some information about specifically why RP-14, this design standard, is not yet in the code. But what I can say right now is people are putting green roofs on all over the place. And what we need to do from a contractor standpoint to protect ourselves is to get code acceptance on each one of our projects. If you're actually written into the building code, you are then quote-unquote code approved, and everybody just uses that information and everybody's fine with that if you're in the actual text within the code. If you're not, what you can do is get an evaluation service from ICC, ICCES, can get you an evaluation service. Manufacturers will provide these, and contractors can then use them on a job-by-job basis to make sure that we do meet the provisions within the building code. And those evaluation services, those evaluation service reports should have adequate information to make sure we can meet the code. So that's how we as contractors can currently meet code requirements. So how about another slide? These are going to go a little bit quicker, but to back up what we're looking at here, I know this is a little tight, but this is language from the brand new 2012 International Building Code. I pulled this offline a couple of days ago. What we specifically look at is, from a contractor standpoint, fire, wind, and impact. Those are all material standards and system standards that we need, system test requirements that we need to meet. What you're looking at here, the top red is actually just a circle around where we talk about wind requirements, and then as you come down, and that discusses wind requirements for all kinds of the other materials that are out there, roof systems that are out there. But at the very bottom there then, where that second circle is on the left-hand side, that already discusses RP4, and you're probably going to hear some conversation from these guys about RP4 as being a basis for RP14. So there's a pretty nice location within the building code for RP14 at this point. So this is where you would look for that in the future. And then the other part here, section 15, 1505 in the lower right is the start of the fire classification section. And Mike, if you want to give me another slide here. And then, so yeah, this is basically just a flip of the page here. Then, you know, within that code section 1505, we get into specific fire classifications. Mike's going to talk about some of the specifics for separation on vegetated roofs and access ways and the requirements that you'll need a Class A roof system in between. You can come to this section here and find out what the requirements of Class A roof assemblies need to be. So that's my left-hand circle on this page here. And then to lead into the next slide, this section 1506 is strictly about materials. Asphalt shingles, built-up roofs, spray polyurethane foam, metal panels. They all have specific material requirements in the code, and now so do green roof systems. Another slide, please, Kelly. So I pulled out these three sections with, I'm still in the International Building Code 2012. So you can see there's a 1507.16 on roof gardens, and that leads you to a couple of different sections within the structural codes about reducing uniform live loads, what we mean by landscaped roofs, what we mean by occupiable roofs. So all of these things are going to be things that your structural engineer is going to take a look at when he's making sure that your rooftop can handle the new loads on top of a building. So this just pieces it all together. So we don't just stop with section 15. That ties into some others, and we'll get into a few more building code issues a little bit later. But just to let you know that there are some things in the building code already, and that we have an opportunity as contractors to get evaluation reports to make sure we're code accepted on specific projects. So that's just a little bit of the codes to lay out what we've been doing now on RP-14. So at this point, I'm going to throw it back to Mike.
Very good. Thank you, Jim, for the great introduction to the issues. Just as a little background on myself, I'm Mike Ennis. I'm Technical Director for SPRI. SPRI is an association representing manufacturers of single-ply roof membranes and components used in the single-ply roofing industry, such as insulation, adhesives, fasteners, etc. Prior to being Technical Director of SPRI, I worked for 30 years for the Dow Chemical Company in their commercial building products division. Next slide. And I just wanted to give you some background of how SPRI got involved in this whole thing. Prior to the 2009 version of the IBC, really with respect to vegetated roofs, the codes were focused on making sure there was structural support that would handle these types of roofing systems, since they are relatively heavy. In that 2009 version of the IBC, however, there was a code change adopted that then required vegetated roofs to meet the requirements of Chapter 15, which is the roofing chapter of the International Building Code. Next slide, please. Specifically, Section 1507.16, Roof Gardens and Landscaped Roofs, was added, which says roof gardens and landscaped roofs shall comply with the requirements of this chapter, being Chapter 15, and Chapter 16, which are the areas that were already in there regarding loading requirements and dead loads, being the ability to handle dead loads, etc. So now what does that specifically mean? Next slide. You have to meet the structural loads. That was already in there. But now you've got to provide documented fire resistance and documented wind resistance. You know, what Jim had said earlier is just making sure that the roofs in general are basically held to the same standard. I mean, you got to all roofing systems up till vegetated roofs had to have these sorts of verify these sorts of performance requirements. So vegetated roofs were also added. Next slide, please, Kelly. So how in the world are you going to do that? How are you going to document fire and wind resistance? one of the wonderful strengths about vegetated roofing systems is the different looks that a building owner can get from using that type of system. These are just a few examples, and you're all aware of many, many more than I am. But that wonderful strength of a vegetated roofing system from a testing standpoint is a real downer, because what ends up happening is, how are you going to test all of those different varieties of roofs, all the different plants, all the different layouts with respect to wind and fire resistance in particular? How are you going to go about doing that? Next slide, Kelly. As Jim had pointed out, there are requirements in the code right now for wind testing. And this is just a picture of a typical wind test, which right now what they do is you build typically it's a 12-foot by 24-foot test deck, and you pressurize it from the bottom side, and you continue to increase pressure until the roof system fails, and then that's how you go about obtaining your wind rating for that system. Well, imagine you put your vegetated roof on that, and you start pressurizing the bottom side. As soon as you get above the weight of that vegetated roofing system, it's going to blow off the roof. So how are you going to go about testing that under the current requirements of the code? Kelly, next slide. With respect to fire classification, again, you build a typical roof component section, and you apply a fire to one end of that roof section, blow about a 12-mile-an-hour wind behind it, and then you see how far that fire propagates up the roof deck. Well, if you're just looking at a fairly simplistic vegetated roof with maybe just sedums on it, you can evaluate that. But what about all those other systems that are out there with the bushes, the trees, the various types of grasses, the various types of conditions? Is it dry? Is it wet? So it makes it very difficult to test these types of systems. Kelly? So as SPRI, what we chose to do is to try to initiate an industry coalition meeting to discuss options. Well, why is this important to SPRI? Because our manufacturers are involved in installing their types of roof membrane systems under vegetated roofs. So we needed to take a look at how we would go about doing this. SPRI was fortunate and was able to hook up with Greenroofs for Healthy Cities, and we worked together to develop a fire standard and a wind standard for vegetated roofs. Now, the way we approached it, because of all the issues that I described, is that we worked on design issues as a design standard versus a testing standard. So how to design a vegetated roof for wind resistance and how to design it for fire resistance. And we did this through a process, and we'll talk about that a bit more, but it's an ANSI process where we get input from the whole roofing industry and a variety of people. And we received extremely valuable input from RCI, Roof Consultants Institute members, of course NRCA, UL-FM, and the vegetated roofing industry members as a whole through Greenroofs for Healthy Cities. So I think that's kind of what I wanted to introduce anyways, how SPRI got involved in this whole thing. Kelly?
My name's Kelly Luckett. I'm the chairman for the Technical Committee for Greenroofs for Healthy Cities. As you can imagine, when we first heard that the building code was going to require some sort of documentation for wind uplift and fire resistance, we were very concerned. It's a very new industry, and we really didn't think that we could survive regulatory barriers. It's already a very expensive item. It's kind of specialized. We've done very well to educate many of the designers and some contractors, and our contractor base is growing every day. We've worked very closely with the NRCA to help educate their contractors. But when this thing first started, it seemed like an insurmountable task, and we really didn't know where to start. We tried to look around to see what was out there. There was the FLL document that came from Germany, but it really wasn't a standard. So it provided some guidance, but we really started from scratch, and it seemed like we were working somewhat independently up until the point where we all started working together and things started really gelling. When we met with the NRCA and then brought their comments into the SPRI meetings and really opened the line of communications, then it really made it easier to develop these things. And the meeting that Mike's referring to in Dallas is coming up on 4 years ago. So it hasn't been overnight. It's taken a long time to get this done. Mike, you want to talk a little bit about the ANSI process?
Okay. Yeah. One thing I do want to say, Kelly, I hope nobody asks us what FLL
Yeah, that would be really
stands
bad.
for, because I have no clue how to pronounce that. That would be a bad thing. Yeah, I'll just talk a little bit. I mentioned earlier that we use this ANSI standards development process in the development of these standards. SPRI is an accredited, what they call SDO, Standards Development Organization for ANSI. And in order for a standard to be included in the code, it has to be recognized as a consensus standard, not just a particular industry segment standard. So that was why it was important to either go through like something like ANSI or ASTM or ISO, someone like that, to develop these standards. So the standard must be developed by one of these consensus organizations. Even FM and UL now participate in the ANSI process to turn some of their standards into consensus standards. Next slide, Kelly. So what you do, you draft a standard. You then develop a canvas list of people that are either considered as producers, people that would be manufacturing products that would be used in conjunction with that standard, users, so design professionals oftentimes would use these standards, or just general interest categories. And you try to have balance in your canvas list. Then the standard is canvassed. If substantive objections are received, the standard is revised and reballoted. And as Kelly said, this can take a while, because these were, we were starting really pretty totally new, other than the guidance we got from the FLL guide. So there were a lot of very good comments, a lot of substantive objections raised, and so we had to go through a number of balloting process. All communications related to objections are sent to all Canvas members, so everybody can take a look at what people are saying, and they may want to change their vote and say, you know what, I agree with what that person said. I'm now changing my vote to objection. So it can take a while. Next slide. So wind resistance of roofs, the ballasted low slope single ply roof system shall be designed in accordance with this. Is this what he had talked about a little bit, what Jim had talked about, there being a section already in the code, 1504.4 for ballasted roofs. If you recall, I was talking about the testing standard in another section of the code where you pressurize the bottom side of the deck. Well, ballasted roofs also cannot pass that or be tested and evaluated per that test procedure. So there was a design standard already in the code, RP4, to handle these types of systems, which are then evaluated by things such as wind tunnel testing and field experience to make sure that they remain in place during exposures in the actual environment. Next slide, please. So the wind design of vegetated roofs. So there was lots of experience with ballasted roofs. We have a pretty good idea of how much weight is necessary to keep the roof in place, but vegetated roofs were a whole new deal. How do you keep that weight in place? So with the lightweight growth media that is often used with these types of systems. So you see a picture here where a sedum-based system was tested 110 miles an hour for 2 hours, just in a standard wind tunnel type test, and it performed extremely well because of the root system helping hold everything together. But what about areas where that vegetation hasn't taken root or is not intended to take root, where you have open areas of growth media? So those were all the types of concerns that we were looking at. Next slide. So the vegetated roof wind resistance, we decided we're going to pursue following the ANSI SPRI RP4 concept, where we design the standard based on things such as building height, parapet height, those types of considerations, and follow that type of of standard and then adjust it accordingly to try to maintain and take into account things like the lightweight growth medium. Next slide. So RP-14 and RP-4, one is ballast of single ply roofs, and ballast on vegetated roofs is RP-14. Roof ballast, river washed large stones, growth media, rough edge, small pieces. So you're dealing with different animals at this point.
Actually, this is Jim's slide. Yeah, Jim, you want to comment on the NRCA's concern about the difference?
Okay, I'm sorry. I'm sorry, Jim.
Sure. Thanks for the intro, Mike. Actually,
yeah, sorry,
actually,
Jim.
Mike.
Thank goodness they can edit these.
Absolutely. One of the things that NRCA would like to point out, and Mike, you just kind of touched on it there right at the end. River washed large stones is what we use on roof ballast. They're very solid. They have really good density to them. We use them to hold things in place. The growth media is more rough edged, oftentimes is smaller pieces. It can be a lot more porous because we're using more pumice-like materials. So it's going to have a lower density, potentially hold more moisture and biological growth, because that's what plants need, obviously, and roots need a place to grow. So it makes sense that we're using them for their appropriate systems. One of NRCA's concerns is, are these things different enough to have a whole standard based on the testing of ballasted single ply truly be equivalent to the growth media on a vegetated roof system? So I know that we're getting further and further down the path on this of coming to some good conclusions on it. We still have some testing to go, and I think what you'll see in some of these wind design, in the wind design standard in some of the locations, is that we recognize there is some difference. So in areas where we are looking for really high-end wind uplift, then we're actually going back to what I will call more traditional systems with pavers, things that we know have a longer track record, and potentially will have less changes while they're in place on site. What I mean by that is small pieces of river wash stone can actually move around when the wind hits. We get scouring at corners. We want to avoid that with our growth medium, and we have good examples of that. So when we have fully Mike, you're the Kelly, you're the horticulturist. When plants are mature, that's what I'm trying to say. When they've taken root and they're established, that's the word I'm looking for. We know that they're not going to just fly out of the ground. That's all good. But like Mike said, what about in the first couple of years? What about edges where maybe we don't want any planting? So there are some differences, but I think because of the ANSI process, grievances, for lack of a better way to say it, differences of opinion, they get tossed out there, they get resolved, and I think you'll find that the result of this is a nice place to be for wind resistance and appropriate design of green roof systems. So are we going to continue to learn things and update?
Well, one of the things
Absolutely.
that
So we'll keep
that we
fighting
found
battle,
out
but,
when we first started
right now
this
we're doing well
was
on it.
there's
So,
the
I'll pass it
the
back to
International Code Council hearings, and that was a very, very unique experience. Some of us have never been involved with that. I know I certainly had not been. So it was surprising to us to see where the opposition to green roofs were coming from, and the NRCA had a what appeared to be an innocuous change that they were requesting was just a simple definition of what was a green roof. And the line of gentlemen that stood up to oppose this relatively simple change was surprising. And they were coming at it from different perspectives, from, you call it a green roof and not a landscape roof, and how does that affect the loading requirements, and what's the difference between a rooftop garden and a landscape roof. And so what we learned here is that the code is very nuanced, and we had to quickly identify the players that were opposing us, and one of them was the body of engineers. And it seemed like we were at somewhat of a standstill for a little while. And I was able to meet one of the engineers on the NCSEA, and I set up a meeting between them and the NRCA, and Mark Graham and I sat down and had dinner with these gentlemen, and I brought this sample. You see me here in these photos. I'm cutting a sample of the 4-inch deep growth media that's completely vegetated and established. And I put it in this little Tupperware, and I brought it to that dinner. And I wanted to show the engineers and the NRCA what it is that we're talking about and how densely the root zone binds this growth media, so that we could agree that completely vegetated, this is not just loose gravel on the roof. And the surprising outcome for that brief dinner was that the engineers were concerned primarily with some of the use of gravel. They're trying to limit the use of gravel on rooftops, especially in high wind zones. And part of what we were working on was the fire design guide. Well, one of the things that we learned from the FLL document was the use of fire breaks and no vegetation zones at the perimeter. Well, what the engineers pointed out is we're taking this gravel, which they consider to be a risk of becoming windborne debris, and we're putting it in the highest in the areas of the rooftop that have the highest risk for wind uplift, which is the perimeter and the corners. So the discussions with that ensued after that were specifically about these no vegetation zones and what are their uses. And as you can see here in these slides, there was no real uniform width of these no vegetation zones. Some of them are very narrow, some of them are very wide, and if we were going to write a standard that called out no vegetation zones or the use of them, we had to agree on how wide this no vegetation area was. And we couldn't find anything in the building code that talked about setbacks, or that we could go back and say, okay, look here, it has to be 30 inches because it says this in the building code. In fact, the only thing that we could find was the setback for vegetation against combustible surface, and I'm relatively certain that that was written for at grade vegetation, but it was 6 feet. So these narrower widths could not be justified in what we already found in the building code. But then it was suggested that if we met certain criteria, namely having a Class A rated surface treatment, that the no vegetation zone may not even be necessary. And if the green roof abutted a vertical surface that was not constructed of combustible materials, again, a no vegetation zone may or may not be necessary. So what we then did was completely change the focus of the fire design guide. And what came out of that is if we are abutting a vertical surface made of combustible materials, then we either have to have a Class A rated fire treatment on the surface of that roofing membrane, or we have to stay back the 6 feet, the distance that we could justify by language that was already in the code. Now, as you can imagine, at first glance, you look at 6 feet, oh my God, we just turned no vegetation zones, practically double what we were using before. So there was some initial concern, but a deeper read, and then you start to figure out, oh, there's all these areas where we're not going to be required to have a no vegetation zone. So what it actually did was brought a lot of green roof area back into the green roof concept by eliminating some of the need for these no vegetation zones. And so our fire design guide basically outlines which areas where they're needed and which situations under which they're not. So that really simplified the fire design guide, and it changed the focus somewhat. And now the core action items of the fire design guide just dealt with when and when not to use the no vegetation zone, and then turn more toward the maintenance of the green roof. And I'm going to hand off to Mike, and he'll tell you a little bit more about that.
Great. All right. Is this, am I going through? Oh, here we go. Okay. The ICC code change process. As Kelly said, that was a new experience for him. Unfortunately, I'd been there before, and it's a new experience every time I'm there. These things are revised, the ICC family of codes. There's a fire code, a building code, a plumbing code, etc. And they're revised on a 3-year schedule. There's a lot of consultation and horse trading that is involved in determining the most effective way to get new requirements into the code. And you need to consider that typically there are anywhere from 1,300 to 1,800 code change proposals submitted in each code change cycle. And many of them cover the same area. And so that's kind of where the horse trading gets in. Maybe I submit something, maybe an NRCA submits something, or somebody else in the roofing industry, or somebody over in this engineering industry that Kelly was talking about. So you try and work together to figure out the best way to move that forward into the code. Next slide. So during one of the horse trading sessions, it was determined that the most effective way to get fire design requirements in the code was to go into the International Fire Code and keep it out of the building code. And another way that what had actually happened was someone with a lot of experience in the fire code had put in a code change proposal where they basically had taken the design requirements out of the ANSI SPRI VF-1 standard, the fire design standard, and just took those design requirements, and wrote them into code language, and then we're submitting them into the code. Next slide. So that is in fact what ended up happening, is that the key provisions of VF1 are in the 2012 Fire Code. Section 316 of the Fire Code shows all the details. I think there's some on here, Kelly. Next slide. Yeah, what we did was included to say area is not to exceed this number of square feet. You have to put these fire breaks in if you exceed that area. Maximum dimension in any one length is 125 feet, and this clearance that Kelly was talking about of 6 feet for a Class A roof surfacing. Next slide. Irrigation. We recognized that in order for this system to perform well in a fire situation, the vegetation should be alive, and you need to maintain levels of hydration. The interesting thing is this kind of sets up some comparisons, I guess, to say the least, between other standards such as LEED and things like that, where they don't want these systems to have irrigation. So in the fire code, we say, yeah, they need to be irrigated. Also, you've got to remove the dead foliage, so there are some maintenance requirements in there. Kelly, next slide. And you have to have a maintenance plan. Now, another interesting aspect of this is now going to be administered by the fire marshals, not the building code officials. So being over in the fire code is
We're actually going to let Jim comment on why it's significant that this is in the fire code and not in the building code.
Yep.
Sure.
The one thing I did want to put in there, Kelly, the last slide back, one slide back.
Right.
Is that, Kelly had mentioned about the Class A separation between vertical combustible areas. Well, one of the things that's been learned through some additional testing that's been conducted at both Factory Mutual and UL is that if you just do a sedum-based system, that can meet the requirements of a Class A fire rating. Now, I don't actually know if anyone has pursued and obtained ratings for that type of system, but testing that was done, and these systems were intentionally dried out and tested under what would be considered some severe conditions, and they still met the requirements for a Class A rating. So I'll turn it back over to Jim.
Sure, and I would just like to follow up there, Mike. Anybody who wants to use the Class A rated sedums, Mike touched on it, you're going to need to find a manufacturer of either the roof system, in the vegetated roof system, whether that's a Carlisle Firestone perspective or a green roof blocks perspective, whichever manufacturer wants to go get that Class A fire rating, you still need that piece of information to give to the building code officials. So as roofing contractors and installers, yeah, you want that information. So good point, Mike. Just real quick on the fire codes. What's interesting, and I want to show you, I showed a slide before that actually showed the written language that, green roofs need to be, vegetated roofs, garden roofs need to meet the requirements of Chapter 15 and the International Fire Code. So that jumps you all the way to here, to the IFC, and just, realize that RP-14 is wind only and not fire. VF-1 was mentioned real quick, so that's a fire code. Scenario or fire standard design guide for vegetated roofs. So again, we still want to be within the realms of the building code. So Kelly, if you would change my slide, please. So we want to get to the International Fire Code now, because that's going to be in the 2012 IBC. It's going to take us over to section, I think, Mike, you said 316. I think maybe we had a switch here or something, and maybe added a section. So 317, whichever. But this is, to show you, this I pulled out again. What's interesting about the fire code is that people are really concerned about fires, death, dying, all that. Not to use really bad words, but the building code is there obviously to secure people's safety and that. So there's a lot of information about fires and suppression and fire ratings, and we keep talking about Class A roofs and all this kind of stuff. When the building code official comes out and says you didn't install that right, we might have a leak. You don't meet the warranty, or you don't meet, some particular portion of my Chapter 15 building code. Yeah, it can be a big aggravation for installers, designers, building owners, but the immediate ramifications are generally pretty small. What can happen with the International Fire Code is that the fire marshal can come out and say to you now that your roof that was installed according to the 2009 code no longer is safe for firefighters to be on it. And you might have the choice of redoing it, or maybe signing something that says when my fire, or when my building gets on goes on fire, and then the firemen come over, they're going to stand here and watch the thing burn to the ground. So the ramifications of this being in the hands of the fire officials makes retroactive reinstallation or retrofits actually somewhat of a real possibility if we really find something that's problematic. So let's really hope not, but that's my shtick on the fire codes. But Kelly, I do have, I think, one more slide, just to enforce what Mike said. The big black line down the left side of this page shows that everything within Section 317 is brand new in 2012. And my point. Mike hit all the topics there.
We progressed nicely developing the fire design guide, VF-1. Once we had the meeting and we opened the lines of communication, it didn't take us long to produce a document and then get into the final round of balloting. but our work on RP-14 seemed to hit a snag, and it was basically we were stating that 4 inches of fully vegetated green roof growth media performs the same as other forms of ballast. Now, there are a lot of people who felt that that makes good sense, but we didn't have any science behind it. So it was somewhat a leap of faith. And we got to the point where we couldn't go any further without some sort of documentation, some sort of testing. So in steps Southern Illinois University, Edwardsville, with their wind tunnel, and the NRCA and Green Roof Blocks, and we got together and conducted the only wind tunnel testing that's produced scientific reports of the results of that testing, and that was a learning experience for us, and it helped us to cross some of those final hurdles so that we could produce RP-14. We started in this testing with 3 hypotheses. The one I just stated, that 4 inches of fully vegetated growth media can sustain a 2-minute wind gust greater than 90 miles an hour. But it gets interesting here. Hypothesis 2 was there's a minimum level of vegetation required to bind the growth media. So it was mentioned before, you know, we're pretty certain that 100% surface coverage with plant life anchors the growth media and it performs very well. But what about when you don't have that 100%? What about a newly planted roof? Or what about, you know, a roof that's in somewhere between newly planted and fully established? So what we wanted to know is, what is the minimum level of vegetation? To date, the industry has been using the 80% rule, and they basically state that after 2 years of growing, you have to have 80% of the surface covered. But what we quickly realized that morning in that room was we looked at several different modules of green roof vegetation with different levels of vegetative coverage, and between the 3 or 4 or 5 of us in that room, we could not all agree on what was 80%. And what we realized then very quickly was, well, if we can't agree on it here in this room, how are we supposed to have a level of compliance that we then are handing off to a code enforcement official, and he's supposed to come out and know what 80% is. So the 80% benchmark is somewhat subjective. So we realized then that we need a more finite measurement of what level of vegetation. So we agreed that we would look at the size of the area not vegetated. So we then tested various sizes of areas that had bare spots, if you will, in the module. So we measured the diameter of these areas, and we started with an area the diameter of 3 inches. And we tested all the way up to an area with a diameter of 6 inches, I believe. And what we found out pretty quickly was that the permissible area of no vegetation is relatively small. In fact, the area as small as 5 inches in diameter would only sustain a 90-mile-an-hour wind. When we went to make that jump in the wind tunnel from 90 miles an hour to 105 miles an hour, growth media started to become airborne. And what we found was that the vegetation is critical in keeping this lightweight growth media anchored. So in hypothesis 2, we determined that the minimum level of vegetation is a maximum area of bare spot 5 inches in diameter. And even then, that 5 inches is only good in a 90-mile-an-hour wind zone. When you get outside that, in any coastal areas or anywhere where you exceed 90-mile-an-hour wind gusts, then you either have to be fully vegetated or you have to have some sort of surface treatment to control the scour, which brings us to hypothesis 3. We knew that there were surface treatments out there. The traditional methods are to roll out some sort of fabric, jute cloth, wind blanket, burlap, and then plant through it. and it's a principle that's been employed at grade for many years. It's new on the roof, and we also knew there's a relatively new technology called liquid binders or tackifiers, and this is a treatment, a chemical treatment that you apply to the surface of the roof that actually binds the particles on the surface of the growth media. And we tested those in the wind tunnel, and they were really surprisingly effective. The one binder that we tested remained completely intact at 140 miles an hour for a duration of 5 minutes. So that exceeded all the different testing increments that we looked at previously for just the bare spot of 5 inches in diameter. So the outcome of the testing proved the hypothesis number 3, that there are surface treatments that are effective in minimizing the scour. And so this gave us some guidance how to write the language in RP-14. First, we had to establish, okay, well, what is protective coverage? So we knew exactly what the diameter was. Anything with a bare spot larger than 5 inches has to have some sort of surface treatment. Now, we wanted to stop shy of mandating what the surface treatment is, primarily because we may come up with a surface treatment in 10 years that's completely revolutionary and is more effective than anything that we've looked at before. And we didn't want to write anything into the building code that would impede future innovation. So we stopped at saying that if you have bare spots larger than 5 inches in diameter, you'll have to take some sort of measure to control the wind scour. With that gave us the science behind the language that we then wrote into RP-14. And we finalized the draft of RP-14, and then it went out for the final round of balloting to become a wind standard. Now, at the risk of putting everyone just absolutely to sleep, I'm going to go through what RP-14 says and how to apply it. We have 3 escalating levels of design. I say escalating, they escalate in wind resistance. So the most lax of the design is what we're going to call ballast number 4. And what this basically says, it sets some minimum weights and minimum criteria for the weight of the growth media, and then it has some restrictions for the modular green roof trays and different module configurations for when they can be independently set and when they have to be strapped together. This is a little more stringent. Ballast number 2, it upped the weight of the growth media, and then it specifically calls out different weights for the modules and again when they can be independently set or when they have to be strapped together. Now, we use 3 different systems with varying levels of those 2 ballast configurations. So system number 1 would say that you could use the more lax standard for the entire area of the roof, even the corners and the perimeters. But when you need a higher degree of wind resistance, system 2 restricts where you could use that more lax design and then makes you go to the more stringent design at the perimeter and in the corners where the wind uplift resistance is higher. And then system number 3 is for areas where we consider wind uplift to be a significant risk. So it uses the more stringent requirement for in the field of the roof and says that you cannot do a green roof in the perimeter and the corners where we consider these areas extremely susceptible to wind uplift. So now we have 2 different levels of design based on weight and connectability, for lack of a better term, connectability of these modules. And then we also have the the three different classifications of wind uplift risk where we're applying these different design principles. Now it's going to get really interesting here. The wind risk, the way we decide if we're using system 1, 2, or 3 is going to be based on several different factors. One is the wind speed of the area of the country in which the green roof will be located. Now you can see the vast majority of this of the continental U.S. is all in one category. It's called the 90-mile-an-hour wind zone. But you see these lines on a fairly tight gradient starting on the left side of the country, and these take the wind speeds up to, in some cases, exceeds 140 miles an hour. You're showing off. Now there's a different consideration called the importance factor. And what the importance factor does is it looks at the category of occupancy for the building. So for instance, a hospital would be considered a higher importance factor than, you know, perhaps an office building, or a small retail store, a 7-Eleven, or a gas station. Now that's significant because what we see here is we have design tables, and we're going to look at where it calls out for more stringent design for these importance factors for buildings fitting the category 3 or 4. And I'll go back here for a second. It's really tight. It's hard to see, but what we're looking at here is where the building, the use is categorized based on if we had total failure, what the loss of life would be, or what the loss of critical services. For instance, the highest importance factor would be like a data center or electrical generation plant, hospitals, areas of high concentration. So where catastrophic failure of the building would mean, you know, large-scale disruption of services or large loss of life. So what we've identified is when the importance factor is in this more serious category, then we're going to increase the level of wind resistance required by the standard. So you're going to increase, if you were in a 90-mile-an-hour wind zone, but you're in one of these higher importance factor buildings, then you're going to increase the wind chart that you consult by 20 miles an hour. And you're also going to increase the level of system, the number system 1, 2, or 3. You're going to go to the next higher level of wind resistance, and I'll explain why that's important here in a minute. We're also going to look at exposure categories. Now, exposure is just what it sounds like. If you're out in the plains of Kansas, you're out there. There's not a lot of trees. There's not a lot of buildings. The surface roughness of the ground doesn't offer a lot of protection. Contrast that to, you know, any urban area where you have a lot of buildings, or there's some trees around, or you have something to block the wind from blowing across a large expanse. So the surface area, the surface roughnesses, we're going to have two categories. Surface roughness B speaks basically wooded areas, suburban areas, urban areas, places where the upwind direction for at least 2,600 feet, or 20 times the building height, provides, you know, some protection from the wind. Surface roughness C is in open terrain. So this is where you would have a building basically out in the open, and you have no upstream protection to the wind. Now, this is where we've been headed here, because I told you about system number 1, system number 2, system number 3. We talked about different wind exposures, and what you see here, there are 6 or 7 design tables, and they vary based on the height of the parapet. So just when you thought you were getting a handle on it, I threw another thing in there on you. The parapet height is also critical in determining what system design we're going to use for a green roof. So if you look at this design table, it first takes into consideration the building height. So if we know what our building height is, we also know what wind zone we live in, or that our building is located in. So we can look at, if we're in a 90-mile-an-hour wind zone and our building is 20 feet high, we're looking at these 2 categories right here. But we're not done. We have to take into consideration, okay, are we in exposure B or are we in exposure C? Now, as we go through these design tables, we can see as the parapet height increases, the level where we can get the wind speed zones also increase. So without being too mind-numbing here, what I want you to take a look at here is see this whole group of areas down here where it says no. And the point I'd like to make here is that not every building and every location is a suitable candidate for a green roof. When you take all these considerations into account and you look at the category of the building, the exposure, how tall the parapet is, how tall the building is, what the wind speed, what the wind zone is in that area of the country, you can get to where you are over here. So as risk is increasing, you're moving from system 1 to system 2, from system 2 to system 3. Well, there are parts of the country and building usages and exposure categories that would require you to go off of this chart, which basically means that you wouldn't be allowed to do a green roof there. So where would that be, for instance? Okay, if we had, just say, a 20-foot building with a 6-inch parapet in Dade County, Florida, which is a 140-mile-an-hour wind zone, and it was going to be a high school, which would be a higher importance factor. We would find ourselves off of the design table, off of the chart, which basically means that we can't build that green roof within the scopes of RP-14. Now, RP-14 has language in it that says that when a project falls outside that scope, then you go out to an outside wind consultant or a wind engineer, and then he has to design a system to specifically meet the wind loading of that particular project. So we're not in RP-14 stating that you absolutely cannot build a green roof, but what we're saying is that RP-14 has a limited scope, and we're not covering every building in every location of the country. It's a pretty good guideline. You can figure out exactly which system you have to follow for your part of the country, your parapet height, your building height, but at some point it stops, and when the level of risk exceeds what we've detailed in these design tables, then you have to go above and beyond what we've allowed here in RP-14. RP-14 should handle the majority of green roofs under construction and being considered. Again, not every building is a suitable candidate for a green roof. And there's a look at the rest of the design tables. I'm going to turn it over to Mike.
Okay, very good. After we recognize that there are examples where RP-14 or where vegetated roofing systems have performed quite well in high wind situations. But one of the things we really want to do is to continue to work to improve these standards. They are required to be reviewed anyway on a 5-year cycle, and during that review process, we want to make improvements on these standards, so maybe broaden the scope, as Kelly has mentioned. So one of the things that SPRI is doing is working with the University of Florida, Dr. David Prevett, to try and obtain funding to do additional wind studies. They have a very large wind test facility there, and do additional wind studies to test some different design configurations and to test some of our theories, quite frankly, to make sure that we're correct in the current standard, and perhaps how we could go out and broaden the scope of that standard. So we will continue to work in that vein. In the interim, we will be submitting code change proposals to include RP-14. These code change proposals are due by January 3rd, 2012 for the 2015 International Building Code. So we're going to go ahead and submit code change proposals to try and incorporate RP-14 right into the code. And the same with the VF-1 standard. Currently, it's in the design elements are in the fire code, but we recognize the International Fire Code is not the rule of the land in as many states as the building code. So we may try to get those requirements over into the building code to broaden the impact of the fire design requirements.
All right.
So that's all
Jim,
I really
where's the
wanted to
NRCA
add
headed?
on those, Kelly.
Well, I think I'm going to expand that just a little bit, Kelly, and just say I think where's the construction industry and design community headed. And just so people know, I'm kind of speaking as an architect right now, sort of, versus a true roofing contractor point of view. But the design community is really seeing vegetated roofs as another avenue for water conservation, bringing more green back to urban landscapes, trying to cool down surfaces. We could have an entire conversation about those three topics right there and everything, but there seems to be a push for it, and it seems like there will be continued growth from a green roof standpoint, and I think water conservation is probably going to be a policy driver that's going to push that. So I see vegetated roofs becoming more significant. So our efforts to make sure that they're durable, long life, meet the building requirements for wind, fire, impact, all that good stuff, I think is really critical, and I see us all moving forward.
All right, here's Jim's contact information.
So I'm excited, and I see more of it in the future.
I'll leave that up there for just a second. Mike is the technical director for SPRI.
Yep, thank you.
And you can download both standards, which I highly recommend. It's very difficult to explain because there's so many factors that go into RP-14. So I highly recommend that you download a copy and review it and go over it. It's a little complicated, but once you get a feel for the different factors that you're considering, and then you start consulting the design tables, you get the hang of it. Both the VF-1 Fire Design Guide and the RP-14 Wind Design Guide are available for download from my website, Greenroofs.com, and also the complete wind tunnel testing report that provided the science behind RP-14. That's available as well. My name is Kelly Luckett. Here's my phone number, and my email address is kelly@greenroofs.com. Thank you, gentlemen.